Greetings to you all. Welcome back to UNIX and Shell Programming. This is Anusha. I am working as an assistant professor from Vignan Srinula in IT department. In the last session, we already discussed about basics of UNIX file systems and commands in UNIX file systems and file attributes and directory hierarchy and file permissions. In today's session, we are going to discuss about inode. So, first one is, what is inode? Inode is a number. It is also known as the index number. So an inode is a unique number that is assigned to files and directories while it is a creator. The inode number will be unique to entire file systems, and inode is a data structure on traditional Unix file systems. Let's see, the next one is file systems. File system is a group of files or relevant information on recording them. The disk space allotted to a Linux file system is made up of blocks. Here each of which of the 512 bytes. To find the block size on your file system, use cmchk command. So, and the blocks belonging to the file systems are logically divided into boot block, super block, inode table and data blocks. Let's see, the first one is boot block. It represents the beginning of a file system. It contains a program or bootstrap loader. This program is executed when we boot the host machine. So, all the file systems contain only one boot block. Let's see, the next one is super block. So it describes the start now let's see, the next one is super block. It describes the state of the file systems. Here state means how large it is and how many maximum files it can accommodate and how many more files can be created, etc. This type of block will be called as super block. And see, the next one is inode table. The information related to a file can be stored in inode table. That is called as disk. For each file, there is an inode entry in the table. Each entry is made up of 64 bytes and it contains details of that file. These details are owner of a file, group to which the owner belongs to the type of file, file access permission, date and time, last access, and date and time, last modifications, and name, number of links to the particular file, and size of a file, and address of blocks where the file is physically present. Okay. This is called as inode table. And next one is data blocks. Actually, it contains actual file contents. An allocated block can belong to only one file in the system. This block cannot be used for storing of any other file contents unless the file to which it originally belongs to is deleted. So, next one is how you can find out the inode number. Here, inode number is also known as index number, and inode is a unique number. It is assigned for files and directories when they were created. Inode number will be unique to entire file system, and inode number is a data structure on a traditional Unix file system such as exe directory. Here, we can store the properties of the files and directories. Let's see the syntax $ls-i file name. So after giving this command, you can get the inode number of IT file. So next topic is typical inode structure. Here, inode structure of a directory, just it consists of a name to inode that are mapping of a files and directories in the current directory. So here in the above shown diagram, you can see the first two entries of dot and dot dot. You might have seen the whenever you list the contents of a directory, most of the times they are hidden. You will have to use a -a option with ls, and people who are more into the Unix or Linux NIX system that knows the command cd, it will change the directory to the current directory itself because you are already in the current directory, and the command cd dot will take you the previous directory. It will be called as the parent directory of the current directory. Now let's see, the next one is difference between capital inode and small inode. Every Linux file system is a directory. Linux or a directory has an inode and inode number. It contains of all the files of metadata. The data needed to read a file is stored in its. For example, inode contains a list of blocks in which a file is stored. The owner information for that file, permissions, all the other attributes that's set for a file. So next, inode limits is for file system. It is decided at the file system creation time. The maximum directory size depends upon the file system, thus the exact limit differs. For the better performance, make your directory smaller by sorting the files into a subdirectories rather having one large directory. So this is small inode, and let's see the capital inode number. Here capital inode number is a known as the index number and inode is unique number. It is assigned for files and directories when it is created. So inode number will be unique to entire file system. Here Linux extended file systems such as the ext directory maintain an array of these inode called as inode table. This table contains list of all files in the file systems. Here individual inodes in inode table have a unique number to that file systems that will be called as the inode number. The following information is stored in an inode table. The first one is file type. It means regular file or directory file or pipe, etc. Permissions to the particular file. You can take three types of permissions: read, write and execute. Next one is link count, the number of hot links related to the inode. Next, user ID means owner of a file. Group ID means group owner. Next, size of a file means minor number in case of some of the special files. Next, timestamp, access time and modification time of changing time of inode. Attributes, immutables for the example. Access control list means permissions for the special users and groups, and link to creation of a location of a file. So other metadata about that file. Next one is how you are mapping of inode with file name in inode data structure. A directory is semantically speaking a mapping from file name to inode. This is how the directory tree abstraction is designed and corresponding to interface between applications and file systems. Applications can designate file names, files by names, enumerate the list of files in a directory. Each file has a unique designator which is called as inode. How this semantics is implemented depends upon the file system type. It's up to each file system how the directory is encoded. In most Unix file systems, a directory is mapping from file names to small inode numbers, and there is a separate table mapping of inode numbers to small inode data. So here the inode data consists of a file metadata such as permissions and timestamp, the location of a file contents, etc. The mapping can be a list or a hash or a table or a tree, etc. So this is how you can, this information can provide how you can map the inode number to file name. Next topic is access of information from inode. How you can access the information from inode data structure. By using ls-l command, you can display all content of files in the inode data structure. So what type of content you can display means file size and modification details and file types and file types, permissions and owner of a file and group of these type of all information can be displayed by using this command. Next one is example of inode. Let's see this example. Here first you can create a one file that is my data. So after that you can execute a command ls-l on my data file. Then you will get the all file attributes related to my data file. It means my data is a file type along with file permissions and number of links and owner of a file, group owner of a file, and my data file size and last modification details of my file and file name. Okay, so next you can take the command is ls-l on my data command. Then you can get the all file attributes related to the my data file. So after using by using ls-il command, you can get the inode number of a my data file. So this is the example of inode number. Okay, now let's see the next topic is inode generation. Here first inode has a 13 pointers 1 to 10 or direct pointers to store the data storage blocks, and next pointer 11 is the indirect pointer. It links to 128 pointer inodes, and each pointer links directly by the user. Here the pointer 12 is a double indirect pointer and pointer 13 is the triple indirect pointer. Here bad block inode is also there. Keep the track of disk of the bad sections. This will be represented by bad block of inode. This is the inode generation. So next one is soft and hard links in UNIX. A link in UNIX is a pointer to a file. Here like pointers in any program or language, links in UNIX or pointers pointing to a file or a directory. Creating a links that can kinds of shortcuts to access a file. Links allow more than one file or name that is referred to the same file elsewhere. There are two types of links we are taking in Unix file system: soft links and hard links. Soft links are also called as symbolic links. So let's see the soft links. These two links behave differently when the source of the link it is moved to the it is moved or removed, symbolic links are not updated. String with the path name or hardware or also refers to the source even if moved or removed. For example, if we take a .txt file, if we create a hard link then to the file, then delete that file, we can still access the file using hard link. But if we create a soft link file, soft link of the file, then you delete the file, you cannot access the file through the soft link. Soft link becomes drag link. Basically, hard link increases the reference count of a location, while the soft links works as a shortcut. So let's see, the first one is hard links. Each hard link file is assigned the same inode value as the original, therefore they reference of the same physical file location. Hard links more flexible and remain linked even if the original linked files are moved through the file systems. Although these hard links are unable to cross the different file systems. Let's take ls-l command. It shows the links within the link column, shows the number of links. Links have the actual file contents. Removing any link just reduce the link count, but it does not affect the other links. We cannot create a hard link for a directory to avoid the recursive loops. If original file is removed, then the link will be still shows the content of the file. Command to create a hard link is $ln space original file name space link name. This is the command for hard link creation. Next one is soft links. So soft link is similar to find the shortcut feature which is used to Windows operating system. Here each soft linked file contains a separate inode value that points to the original file. As similar to the hard link, any change to the data in the either file is reflected in the other. Soft links can be linked across the different systems. Although if the original file is deleted or moved, the soft link file will not work correctly. Let's take ls-l command. It shows all links with the first column value and the link points to the original files. Soft link contains the path for the original file, not the contents. Removing the soft link does not affect the anything but removing the original file. The link becomes dangling link which points to the non-existent file. A soft link can link to a directory, link across the file systems. If you can link a file across the file systems, you can only use the semantic link or soft link. So what is the command we are using for creating a soft link? $ln space s -s original file name space link name. This is the command for soft link creation. These are the two types of links we are taking in UNIX file systems. So these links are used for creation of inode. Okay. So I hope you understood this topic. Inode is the data structure that describes the attributes of a file, including the layout of its data on the disk. And here we can take two versions of the inode, disk copy and in-core copy. Disk copy means it stores the inode information when the file is not in the use. In core copy means record the information about the all active files what you are taking in the current version of the inode. So inode disk blocks, here we can take directories. Directories means here files that are correlate with the file name components to inode members, and name of file, it converts the file names to inodes and inode assignment and disk block of assignment. Okay, this is the summary of inode data structure. Okay, so after listening this lecture, now you can evaluate yourself by using these three questions. The first question is explain about the inode data structure, and the second question is how you can access the information from the inode data structure, and the third question is explain about the soft links and hard links in UNIX file systems of inode. These are the three questions for evaluate yourself. Okay, thank you for listening. Thank you.